Assalamualaikum dan selamat sejahtera. My name is Muhammad Iqmal Haris bin Abdul Hafiz. So today I'm going to make a demo video for my final year project, which is Selective Harmonic Elimination technique using Crayfish optimization algorithm for 7-level Cascaded H-bridge multi-level inverter. So I'm using the two medium for my simulation, which is PSIM and MATLAB. I'm using MATLAB and PSIM because as the primary simulation in this primary simulation platform, due to their complementary strength in numerical computation and power electronic system simulation. So MATLAB is widely recognized as their powerful mathematical and algorithm development, make it an ideal medium for me to do optimization algorithms such as Crayfish optimization and Newton Raphson. So we are using MATLAB. So in MATLAB, we set up for Crayfish optimization algorithm coding the functions. So after we put all the functions here, where the shift fitness, main, and Crayfish calculation of the THD and the objective function. So we have to run all the functions in main. So after we run, we will get the value below. Let's say that right now I'm run from the modulation index of 0.5. So this is all the answer that I have because I'm use the answer to do the looping for the answer for 10 times. So after that, we are recording the data from modulation index 0.1 until 1.00. So we recorded all the data in Excel. We choose for each of the modulation have 10's value. So all the 10's value, we will pick the best THD, the lowest THD. So this is all the recorded value for the best value for each modulation index. So we gain all the modulation index from 0.01 until 1.00. So from here we pick 2 points in Crayfish optimization algorithm to simulate in PC whether to see the answer that developed in MATLAB for the value of the THD. Is it the same with the computation in the MATLAB? So after that, we are using PSIM. So right now I'm using this circuit to run for the 0.99 modulation index of the Crayfish optimization algorithm. So after we run, we go to the VR and we can see this is the 7-level step output of the multi-level inverter. So we can press the measure to see the THD. So this here the frequency is 200, so we have to adjust it at 50. So when we adjust it to 50, the THD will go around 1.288 -0.1, which is equal to 0.12882. So for the THD system, we are using times 100 for the percentage. So right now we roughly get about 12.88%. So after we go back to the Excel, we can see for the 0.99, that THD that we get is 11.67. So in the PSIM simulation, we can see that it have a slightly different from the answer that we get from MATLAB. So after that, from the simulation, we want to make sure that the hardware implementation is it same with the simulation that we are going to do in this final year project. So we will download the program into the Arduino board here. So right now we have to turn on, and then we will turn on the supply. This is for the DC for H-bridge 1, DC for H-bridge 2, and H-bridge 3. This is when I turn on the DC power supply for the first bridge. So this is the output for the DC power supply for the first bridge, and then I turn on the first and the second. So we could see this is the power output. This is the output for the bridge 1 and bridge 2. And then when I turn all together, the 3 DC power supply, and it will produce the 7-level output in the oscilloscope. So right here, I will have to take value from here to see whether the frequency is around 50 Hz. Yeah, of course they have plus minus, but the plus minus make sure not too big and not too low. So right now, what I want to see here is the harmonic distortion. So we can see here harmonics. So I'm taking the data for the fundamental THD, so we can see the THD producing is 12.1%. So that's all for the hardware.